and filling out a chart for the tangent. So let's go ahead and kind of get started on this then. Okay, so we're going to use the unit circle, okay? And the idea with this is we know the tangent. What's the definition of the tangent? Y over x. Okay, sine over cosine's fine, but y over x. We're going to look at the unit circle. So we're going to go around the unit circle and we're going to do y over x real quick. Now this time I'm going by 45-degree increments. There's a reason for that. I'll show you that in a minute. And then just in our head, we'll be able to go through and do y over x. Okay? So what I'm going to do is I'm going to start with 0 radians. So y over x is 0 over 1, so the tangent of 0 is 0. Okay, we go to the next one. Now do this one in your head. I'm not going to write it down. What's square root of 2 over 2 divided by itself? 1. Okay, so that's 1. Okay. Then go to the next one. Pi over 2. Y over x is 1 over 0. So what's that? Undefined. That's going to mean you're going to have a vertical asymptote. Okay. Then we go to 3 pi over 4. In your head, what's that going to be? -1. It's the same number divided by itself, right? But you have a positive divided by a negative. So that's going to be -1. Okay. Go to pi. Okay. At pi, you've got y is 0. X is -1. So you got 0 like that. Now that's a pattern. You're going to kind of see a pattern. All of these trig functions have 5 key points. So you kind of got a 0, 1, undefined. That's really a cycle. But what we look for is like 2 asymptotes basically. So if we went with the negative angles like this, if we went to negative pi over 4, negative 45, y over x there is going to be back to -1. If we do negative pi over 2, what's y over x there? Back to undefined. So see, now it's just cycling through the same pattern. Now if you go to negative 3 pi over 4, okay, you're going to have y over x there. That's going to be back to 1. And then if you go finally to negative pi, that's clockwise, then y over x there is going to be equal to 0. Okay, do you guys see how I did that? Nothing to it. Tangents y over x, go around the unit circle and compute y over x. Okay? Now what we're going to do is we're going to create that graph. Now there's a couple of things I want to show you on this. Is the period's a little different now. Okay, so what I'm going to do just for a point of reference is right there what I just highlighted as a period. Okay, there's an asymptote. The way I think of a tangent is it's got an asymptote, then it has a -1, 0, 1, then another asymptote. It's going to repeat that cycle forever and ever. So how far apart are these two numbers? Negative pi over 2 and pi over 2? Pi, good, okay. From 0 to pi over 2 is pi over 2, agree? From 0 to negative pi over 2 is another pi over 2. So pi over 2 and pi over 2 is pi. Now that's different than the other trig functions. All the other ones we looked at had a period of 2 pi. So that means that the period of the tangent, you want to write that down, that's important, that's equal to pi units, okay? And then let's write down kind of where we're undefined. We're going to look for a pattern on that just kind of to start with. All we've really found so far on this, if you look at your table, pi over 2 we were undefined, and we were undefined at negative pi over 2 like that. Now what happens on this is since the period is pi, if I take this asymptote and I add pi to it, it'll tell you where the next asymptote is. So I'm going to put that over 1, get a common denominator. What's the result of all that? 3 pi over 2, right? So what's going to happen is every time you add pi to wherever you are, you're going to get another asymptote. All I'm trying to do is just kind of help you see the pattern. Okay, now, can you see the pattern? 1 pi over 2, 3 pi over 2, what's next? 5 pi over 2. Okay, so we got 5 pi over 2, 7 pi over 2, so what's happening? Got odd numbers, don't we? So it's like an odd integer pi over 2. That's how that goes. Okay, it's going to have that same pattern forever and ever. Does that make sense? All you're doing is the 2 places where the tangent's undefined are at pi over 2 and 3 pi over 2. And then if you keep circling, going around the circle, you're going to be back at those points infinitely. Okay? All right, let's go to the next page and let's now do our graph. So that's the table we did. So let's go ahead and get everything set up. So we want to get our x-axis set up. So we're going to start with pi over 4, then pi over 2, then 3 pi over 4, and then pi, just using that. We go by a little bit different increment because the period's different. And then we want to do negative pi over 4, negative pi over 2, and so forth like that. So you want to get all that put together, okay? So here's what we're doing, and we talked about this in the last section, is when you increment your y-axis, what we always do, regardless of the trig function, is take the period and divide it by 4. Okay, we just said the period of the tangent was what? Pi, so pi over 4 is what I'm doing. So what I'm doing on my x-axis is I'm going 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so forth. Does that make sense? You always take the period and divide by 4, and that tells you how to set up the x-axis. So that's real critical. Now let's go just like up to 1 and down to -1 like that. Now we'll put it all together. That's all the points you need anyway. So what I'm going to do is start with the vertical asymptotes. Okay, so I'll have you go through and put a vertical line through pi over 2 like that. And then we'll put a vertical line through negative pi over 2 like that. So you want to draw your asymptotes like that. And then just plot your points. So what we have is 0, 0. You have pi over 4, 1. And then you have negative pi over 4, -1. And that's all you want to see. And then what happens is the graph goes like this. It just connects. And anytime you have a vertical asymptote, the graph gets close to the asymptote but never touches it, and either goes to infinity or negative infinity. So if you look at this piece down here, the graph's going to go more like that. Okay, does that make sense? Now all I'm doing is y over x. That's what tangent is. And once I get those values, I'm plotting it. Then if I continue this, I have 3 pi over 4, -1, pi 0. And what that is that's like half of the period right there. So I just do that. You move over here, we have negative pi 0, negative 3 pi over 4, 1, and so forth like that. So there's your tangent, okay? So it has kind of a different structure to it like that. So the idea is the period is defined by the asymptotes. Your 5 key points are asymptote, -1, 0, 1, asymptote, like that, over and over and over again. Does that make sense to everybody? Is there any question anybody has with how I created that graph? Okay. And what happens is, if you did a tangent, and I'd like to just show this real quick on the calculator. If I did something like, I'm going to put myself in degree mode because it's just a little easier for you to see. So like if I did the tangent of something very close to pi over 2. Pi over 2 is like about 1 point something, 1.7 or something like that. So if I did the tangent of 1.6, okay, I get, whoa, I didn't do that right. Let me do that one more time. Oh, I'm in degree mode. That's why it was messing up, okay? That's why I put it in my calculator in degree mode. So pi over 2 is 90, right? So let me just show you what happens if I did the tangent of 89.99. What kind of number am I getting? A real big one, right? So the idea is if you're barely to the left of pi over 2, tangent just gets big. Does that make sense to everybody? I mean, that's the way vertical asymptotes work, okay? X and Y have a ratio that gets infinite, okay? All right, now what we're going to do is we're going to answer a few questions about this. So first of all, I want to kind of repeat what we did on the previous page. We said that we have vertical asymptotes at pi over 2. That's a place where the tangent's undefined. We also had one at 3 pi over 2, okay? Because if you go there, you got another place where y over x is undefined. And then from there, what did we conclude? 5 pi over 2, 7 pi over 2, and odd numbers, right? And then if you go into the negatives, it goes negative pi over 2, negative 3 pi over 2, and so forth like that. Okay, so can anybody tell me what the equation of the asymptotes would be then? X equals what?
X equals k pi over 2. K is not.
There you go, k pi over 2. Because see, what's in common is you always have a pi over 2, right? You always have pi over 2. What's changing is that odd number. So you just have k pi over 2, like that. So again, you want to get used to doing this because you have to write formulas on these. So you want to write down the formula for the vertical asymptotes is x equals k pi over 2, like that. And then you say k is an odd integer. You just write that out like that. And I know like when you're doing this on my math lab, they usually do this in multiple choice. like with these asymptotes, so that you don't have to type in odd integer, but you usually have to fill in the k pi over 2. It's usually odd, even, or it can be something else depending on how complex it is, okay? All right, does that make sense to everybody? Okay? All right, and we don't have a minimum, and we don't have a maximum, okay? So since the graph gets infinitely high y values and infinitely low, that's how that goes. So that's the idea of the basic simple tangent, and then what we do is we change that by doing transformations, okay, period changes and stuff like that. Okay, so a couple of things that are a little different on this. We're going to focus mostly on this format. We've already talked about this. Now, A is usually we think of that as the amplitude. However, a tangent does not have an amplitude, so you might want to write that down if you need to. So a tangent has no amplitude because it doesn't have a max or min. Okay. The only two trig functions that have an amplitude are sine and cosine. They have a max, they have a min, and remember the amplitude's half the distance from the min to the max. So if it goes out of control and goes to infinity, then you don't have an amplitude. Okay, omega is basically change in the period, so this time the formula is pi over omega. That's different than the sine, cosine, secant, cosecant, which are 2 pi over omega. Okay, so you got to pay attention to that. And then the B is up, down stuff like we talked about, okay? All right, any questions about the basic graph so far? Is that okay? Tell me, I don't know. Give me some feedback. Okay, okay. All right, very good. Now, what we're going to do is we're going to go to this. I'm going to show this real quick real quick. I mean, I've already got the graph, but I want to show you what these GeoGebra apps, what they have on the internet, a lot of times show you how a unit circle converts into a trig function. I'm going to run through this one real quick and just kind of show you how a tangent works now. So the way this goes is you're just graphing y over x like we did. Okay, y over x at this point is 0. And then if I make it to like 45 degrees, when you do 45 degrees, the point on the unit circle is root 2 over 2, root 2 over 2, so it's 1. The tangent's 1. Okay, it's hard for me to get at 40. Oh, there we go, 45, like that. Okay, so what's happening as I continue through this, well, that just gets out of control. And then eventually when I get to 90, what we concluded is we're undefined. So all this unit circle's doing is doing the ratio of y over x, and as it's doing that, it's tracing out the tangent. Isn't that cool? No response. I think that's incredibly cool. Okay. All right. Okay. Didn't have that when I was a student way back when in trig. We didn't even have the internet back then. Okay. Had a library. Okay. So let's go to the transformations now. So we're going to work on transformations. What I'm going to try to do in this section is do a basic tangent and a transformation, a basic cotangent and a transformation like that. Okay. So first of all, this one's got several things going on in it, and let's identify a few things. When you see the 3, that's going to tell you that that tangent graph's going to move up 3. If it was minus 3, it'd go down 3. This thing right here is going to give, omega is going to be 2. That's going to give a period change. So what that's going to do is change the width of the shape that repeats. Okay, then this thing right here, it's not an amplitude. What it's doing is it's multiplying y values on the original graph by 2, so what it's doing is stretching. So if you can imagine that tangent graph, it gets stretched out because the y values get bigger. So that's the idea. So when you do this kind of a problem, you always want to start by figuring out the period if it changes. So the formula for a tangent is the period is pi over omega, like that, okay? So that's going to be pi over 2 now with omega being 2. All right, so that's the period. So it's going to be kind of shrunk this way, okay? Now, the next thing I'd like you to do, now this is what's different about doing a tangent. The way I try to teach a tangent is, your goal needs to be to find 2 asymptotes. If you can find 2 asymptotes, you know where the period starts and where it ends. And then you can find those 3 key points in the middle. So here's the easiest way to do this. Okay, first of all, what you do is you set the argument equal to pi over 2. What I mean by the argument is this thing. It's whatever's in the parentheses, because that's changed. We call that the argument. So what I'm going to do is have you write this down. Just write down the 2x and set it equal to pi over 2. Now, why in the world am I setting it equal to pi over 2? What is the significance of the tangent at pi over 2? What's y over x? It's undefined. So if I solve that equation, I will have where that asymptote went to. Okay? So you always do that. You don't memorize that you set it to pi over 2. You understand it. Unit circle tells all. It's the god of trigonometry, I always say. So pi over 2 is where the tangent doesn't exist. Okay, so now we solve this equation. So you could multiply both sides by a half to get that by itself. So that means you would have an asymptote at pi over 4. That's where you have like your first vertical asymptote. That's changed. Okay? All right, so that's the idea. Now to help you understand that, see the idea with this is if you do the tangent of 2x, which is what you're doing, the tangent of 2x, what happens when you do 2 times pi over 4? What do you get? Pi over 2, right? Right, what happens at pi over 2? Undefined, you see what I mean? So when you multiply that new number by pi by 2, it just takes you back to where you're undefined anyway. Does that make any sense? So you can tell you're right. You can tell that you have an asymptote, okay? Now the next thing I like students to do is this, is if you want to find the next asymptote, you have 2 ways to do this. I don't care which way you do it. One way to do this is you just say, okay, pi over 4 plus the period. Okay, the period on this was pi over 2. Okay, so what we're going to do on this to find the next asymptote is just add pi over 2 to it. Okay, you would get a common denominator, which of course is 4. So if you did that, you would have pi over 4 plus 2 pi over 4. So that means the next vertical asymptote is going to be at 3 pi over 4, like that. So what we have is we've got this asymptote, now we have that asymptote. So the thing is, when you do a tangent, if you can figure out where 2 asymptotes are, then you got it made. Okay, now you got to figure out what happens in between it, and then you'll have 1 period. Okay, does that make sense? Okay, now you can also do this. You don't need to write this down unless you want to. You could also take the argument and set it equal to 3 pi over 2. If you set it equal to 3 pi over 2, that's the other place where y over x is undefined, right? 1 over 0 is undefined. So notice if you do this, you'll get the same answer. So if you go through and do multiply by a half, look what you get. You get 3 pi over 4. So you can do it that way if you want to. It doesn't matter. Okay? So is that solid with everybody? Okay? If you have an asymptote, find it. And it always works that way. Okay, now the next thing, this is a typo. I think your note says 2 there, doesn't it? Divide the period by 2. That's 4. It's always 4. Always, always, always. So please correct that so you don't mess that up. Every trig function can be thought of as having 5 key points. So what you want to do is just take the period and divide it by 4. So that would be, let's see, the period was pi over 2. And if you want to multiply it by a 4th, that's what dividing by a 4 is anyway. So you would have pi over 8. Okay, now what does that mean? That means when you make your table, we're going to make a table on this problem. We're going to make the table go by pi over 8s. Okay, so I'm just going to start kind of counting this out. Okay, now what I'm going to do on this one is when I make this table, and this is the way I think students usually do the best job on a tangent and cotangent, just make a table and number crunch. So what we're going to do is take your first asymptote. We're going to go ahead and start at 0. Okay, and we're always pretty well going to do that until we start studying the phase shift. Now just start counting by pi over 8. And we'll take this out a little further too. Okay, now you don't have to write this out unless you feel like you need to, but when you count this out, what am I doing? I'm counting by the numerator, like that. So you just keep counting that out by 1 pi, 2 pi, 3 pi, 4 pi, and it's all over 8, and then you reduce as you go. So 2 pi over 8 is going to be pi over 4. That's a place where we found that we had a vertical asymptote, so I'm going to put undefined there. Then I go to 3 pi over 8. Okay, then I go 4 pi over 8 really reduces to pi over 2. Okay, then if we kept going, what would come after that would be 5 pi over 8, like that. Okay, then if we go one more time, we'd have 6 pi over 8, but that really reduces to 3 pi over 4. So it's probably a good idea to take the table out one more step like that. okay? So again, what I did, what you got to kind of keep track of is the period is pi over 2. I take a fourth of that to figure out how to increment those numbers. Does that make sense? Okay, then I just count it out. You'll be able to count that out in your head and reduce as we go. Now, where are our asymptotes? Pi over 4. Where was the other one? 3 pi over 4. Count. 1, 2, 3, 4, 5. Aha, we made it to the asymptote. Okay, that's how you know you're doing this correctly. So you've got your 5 key points. So what we do is we're going to go ahead. We have that. Now, what we're doing on this is you want to make a note that what I'm having you make a table of values for is y equals tangent just of the 2x part. The way that I try to get students to learn all of their trig functions is the same way. If you go back to the original problem that we're doing, you always, when you have a period change, you don't focus on the 2 or the 3 until the end. You just get this filled out and you don't have to do any number crunching whatsoever. Okay, so here's the way that I try to get students to remember this. Okay, if you go back to the basic tangent, I'm talking about the one that we did up here, look at your table on the basic tangent. Halfway between the asymptotes, you had a 0, right? To the right of that, you had a 1. To the left of that, you had a -1. So we're not ready to change that yet. So what I'm going to have you do is just do the same thing. Just put a 0 there, put a 1 there, and put a -1 there. Okay? Then just kind of go backwards, okay? 1 would match with that. 0 would match with that. Okay? And see what you have right there is you have 1 period right there. Okay? Now when we take the number in front of the tangent and the +3, now we're going to change that. Okay, does that make sense? So all you got to remember on a basic tangent is undefined, -1, 0, 1, undefined. If you forget it, you go to the unit circle. Okay, now what we're going to do next is we're going to do this. So we're going to start over again and just kind of refill in these radians like this, and we're going to adjust the y value. So we're just going to number crunch. Okay, asymptotes are still asymptotes. They're set in stone. They aren't going to be affected by anything else in the problem. So what we're going to do is in this table, we're going to do the whole thing together, which is, I already forgot what I'm graphing here. Yeah, 2 tangent of 2x plus 3. Okay, that's what we're graphing. Now, the rest of this is super, super easy arithmetic, so please watch carefully. Okay, I'll start here. All I'm going to do on this point is I'm going to do 2 times 0 plus 3. And you're going to do that over and over again, and you'll be able to easily do that in your head. So what's 2 times 0 plus 3? It's 3, right? That's where that point is now moved to. Then you go to the next one. Now you take the y value and you do the same thing. So you're going to do 2 times 1 plus 3. So what's that? 5. Okay? Now I want to ask you a question. What's the distance between 3 and 5? 2. That's the significance of that number 2, by the way. Okay, that's what that did. It changed that from a distance from 0 to 1 to a distance from 3 to 5. Now you do the same stuff. From here, you do -1, so you're going to do 2 times -1 plus 3. So that looks like that's 1. When you go back to that one, we already did it. So you do 2 times 0 plus 3, that's 3. And then when you go to this one, we already did that too. That's 2 times 1 plus 3, so that's 5. Now we're ready to graph. Okay? That's the easiest way over many years of teaching trig. So to me, it's the easiest way to get students to do this well. What do you think? Okay? Because if you get the asymptotes and get all those, the increment of your x-axis, then all you got to do in that last step is then figure in this number and that number at the same time. If you had a negative there, that would reflect, but you go ahead and just compute it there and it'll reflect for you. So you turn it into more of an arithmetic problem when you do this then, okay? All right, is there any questions about what I did there? Tell me honestly. Is that looking okay to everybody? Thumbs up, thumbs down, tell me something. Okay, I don't know. I see lots of smiling faces, but I don't know if you know what's going on or not. Okay, now there's one thing I want everybody to write down, please. I meant to put this in your notes, and it's incredibly important that you put this here. okay, we have a formula for the vertical asymptote of a tangent and cotangent. You want to go ahead and write that down. You always have to figure out generally the general equation of your asymptotes, and most of the time you try to just look for a pattern. Most of the time it's like k pi something, okay, with k being an integer, odd or even or something like that. If you ever have a hard time, and a lot of times students do, and I do too if the pattern's complicated, you just do this formula. So what you could do is we would basically do this, and I'm going to go ahead and do this on this problem right now. What you do is it's x equals the first asymptote you found plus the period times k with k being an integer. And the reason you do this is because this. You got to understand the y with this, otherwise you'll forget it. Okay, what happens? There's your first asymptote, pi over 4. So what happened at the end of the period? You got another asymptote. So you're just taking the first asymptote plus the period, and then k is an integer. And then from then on out, you would just go on forever and ever like that. You always, if you're going to use this formula, use k as an integer. So let's go ahead and write that out. So the way you would write this is x equals the first asymptote. That occurs at pi over 4. Okay, what did we find the period to be on this problem? If you look at higher in your notes, what did we get? Pi over 4. We got pi over 4. So we say pi over 4 times k, and we say k is an integer. Now remember, that's the symbolism I taught you last time. That funky looking z is an integer. That's just saying k is a member of the integers. 1, 2, 3, 0, -1, -2, so forth like that. There you got it. Okay, sometimes that's the hardest part of the problem for students. But if you use that formula, you'll always get it, okay, with ease. Okay, what do you think? Okay, all right, let's go ahead and graph this now and put this together. And then we're going to move on and look at a cotangent, okay? So, yeah, you got to get everything set up. So we're just going to, this time I'm just going to start at 0 and go to pi over 8. And then kind of work through the cycle like this. Okay, you can do the negatives. I'm not going to bother doing the negatives. Once you get one period, you should be able to go as far out on this thing as you want to. Okay, like that. All right, so you want to get everything kind of set up like that. And then we have a highest y value of 3, or not 3, 5. So I need to go up to at least 5, and then that's good enough. Because all we're going to do is sketch the shapes anyway, like that. So again, you want to get everything set up. Always label, you know, what your x-axis is and what your y-axis is. You got to do that. And then what I'm going to do is just, let's do the asymptotes. So we have asymptotes at these two values. So we have an asymptote going through pi over 4. We have another one going through 3 pi over 4. Okay, then we just plot points. Okay, then from there we just sketch it. Okay, so it looks like we have 0, 3, pi over 8, 5, and then you just make it kind of, just sketch it, make sure that it's approaching the asymptote. That doesn't have to be accurate, it just has to have the right shape. Okay, 3 pi over 8, 1, then you have pi over 2, 3, then 5 pi over 8 like that, and then again you just sketch that like that, show that it's getting close to the asymptote like that. Okay, one thing that you might want to make a note on here, this point right here that's in the middle, we call that usually an inflection point. If any of you have taken calculus like in high school, did you ever learn about inflection points, any of you? It's just a nice term to know for a tangent and cotangent. That's just where it kind of in the middle of the period is what that is. Okay? Okay, so what do you think? Okay, all right. So we're going to do the cotangent, and we're going to do the cotangent exactly the same methodology. There's going to be one little slight twist in it, just one little slight twist, and that's it. Okay. All right, so we're going to start over again. Now we're just going to do the basic cotangent, and we're going to build the basic cotangent graph. Then we're going to do one with a transformation. Okay, so you want to be able to do, usually the way I test over tangent and cotangent, I usually don't put lots of transformations in it. The problem I just did is a good example. That's as complicated as it'll get. So when we do a cotangent, first thing you need to know is the cotangent of theta is x over y. Okay, so you're going to go around the unit circle and you're going to figure out x over y. And it's not going to be much different than y over x, but you'll kind of get this. So I'm going to go by 45-degree increments, and then we'll just go through and fill those numbers in. You just do this in your head, okay? So starting with 0, x over y, you have 1 over 0, so what's the deal? You have a vertical asymptote, you're undefined. It's in a different place. Now you go to the next one. What's y over x at 45? 1, right? You do that in your head. Y over x is the same thing. Okay, pi over 2. You've got 0 over 1. Remember, we're doing x over y now, so that's 0. Go to 3 pi over 4. What's that going to be if you do x over y? -1, okay. Then you make it to pi. So when you get to pi, what do you have? X is -1, y is 0, so what do you got? You have an asymptote. Right there is the period, okay? So if you look at this, it's going to cycle through this forever. Asymptote. 1, 0, -1, 0. So it's backwards of the way the tangent was. Has the two asymptotes, 0 in the middle, but the 1 and -1 are different. Okay, that's the only going to be the only key difference. And then if you went through like this, I don't know why I put a 3 pi over 2 there. That's unnecessary. So I'm not going to do that. So we just go backwards with this. So if that's -1, so is that. If that's 0, so is that. And if this is 1, that's a 1, and then the asymptote goes like that. So you just go through the unit circle to do that the same way. So what I've done in my table of values is I've got 2 periods like that. Okay? All right, is that reasonable? Okay, the unit circle tells all. It's all there. It's all embedded in that magic diagram. Okay, the period is pi again. If you look at your diagram, a period would be this right here. From 0 to pi represents a period right there. Okay, so that's pi units. Okay, and the cotangent's undefined. Let's just kind of write out what we found here. So it looks like we're undefined at 0, pi, and -pi. Now let's see if while we're at it, we'll see if we have a pattern. So I'm going to just write that down as 0, pi, -pi like that. Okay, now here's the deal. It's very easy. I said the period's pi. So what's pi plus pi? 2 pi. Then what pi? 3 pi, 4 pi, 5 pi, 6 pi. So what kind of pi is that? 1, 2, 3, 4. That's integer pi, right? Okay. So the pattern exists in this one. It's not k pi over 2. It's going to be k pi this time, right? So you can just kind of make a note that that thing goes out forever like that. You got to look for the pattern. Okay. All right. Does that make sense? Okay. All right, so let's go to the next page. We'll go ahead and do a graph on that and kind of put that together and get that done. Then we're going to do the questions, then we'll do one problem that's got some transformations in it. Okay, so now you got to go ahead and get this put together. Pi over 4, pi over 2, and let's see, then we got 3 pi over 4, and pi like that. That's as far out as you need to go that way. And then just do the negatives. We'll take this through 2 periods. Okay, like this. All right, and we'll go up to like 1 and then leave a little bit of room from there. And then it's just a matter of locating everything. So the way that I like to get you to learn this is find the asymptotes and do those first. And that's giving all the places where the cotangent's undefined. So we're going to have that. Okay, and then you want to remember this on a cotangent, just like the tangent. What happens halfway in the middle of an asymptote? Where are you? 0. Okay, that's what we usually call the inflection point. So halfway in the middle, you're there. And then it just goes backwards. If you plot your points, like it's going to go like this. So it's going to almost look like a reflection of what the tangent is. So that kind of looks like that. And then same thing with this period over here. All I'm doing is just plotting the points that we got from the table of values like that. Okay, so that's cotangent. Okay, so one of the things you probably noticed by now is the sine and cosine are very similar, aren't they? So are the secant and cosecant. So are the tangent and cotangent. Okay, and those things are co-functions of each other, have a very strong relationship to one another. Okay, their graphs look the same. Okay, so let's do the asymptotes. Okay, and we already found the pattern was 0 pi, 2 pi, and so forth. Okay, so tell me what the equation of the asymptotes would be. X equals what? K pi, with K being what? A regular old integer, right? Okay, it's always got a pi in it, but the number in front of pi is going to be 1, 2, 3, 4, and so forth like that. So we would have X equals K pi, okay, and then you just say K is an integer. If you want to use that shortcut and abbreviate it as K with the epsilon and the Z, you can do that, okay? All right. Then from here, let's see, just like the tangent, we do not have a max. We do not have a min. Those are kind of the fundamental parts. And then we'll have basically everything will be the same. We will have, this will be the formula for the period. It's pi over omega. And then the translations all work the same as they did on the tangent. Okay? All right, so is there any issues or anything I need to clarify for the cotangent graph with anybody? Okay, all right. So let's do one that's got some transformations in it. This is kind of what you're leading up to. So let's go ahead and put this one together. We have 1/2 cotangent 3x minus 2. Okay, we're going to graph that without a calculator. We're just going to, if you follow this procedure, you will thrive, okay? You will do well. All right, so let's think about what this is. Tell me what the minus 2 is going to do. Is anybody out there? Down 2. Okay, we got that. All right. All right. What does the 3 do? What does it change? The period. The formula is pi over omega. So that's going to do the period change. What does the 1/2 do? Shrinks it. Okay. Really, the way I like you to kind of think about this, you're correct about the shrink. It's multiplying y values by 1/2. And that's what's causing it to flatten out. The y values get smaller because when you multiply a number by a fraction, it gets smaller. Okay, that's the idea. Okay, so here's what we're going to do. The period is where we need to start. The period is formula is pi over omega. So omega is 3. So we have pi over 3. That's very important. We now have established the period's pi over 3. So we need to now find the asymptotes. Now this is the whole key to the problem, is going through these first 4 steps. You do that, you'll do well. Okay, so what we do is we take the argument. Remember, the argument is that thing right there. That's what you're taking the cotangent of. And you're going to write that down, and you're going to set it equal to 0. On the tangent, I had you set it equal to pi over 2. Let me see if you're on top of what I'm doing here. What's the significance of the cotangent at 0 radians based on that point? It's undefined. Remember, it's x over y. That's what's significant. So if you set that equal to 0, you're going to figure out where it changed to. Where's the other place on the unit circle where the cotangent's undefined? Pi, right? Okay, so what you can do is you can do this like this. Well, this is an easy equation to solve. You just do that in your head. So that would mean your first vertical asymptote is x equals 0. So that's vertical asymptote number 1. Okay? Now, the next one, you got 2 ways to do it. You could either just say x equals 0 plus the period. So the period is pi over 3. Okay? Once you get the first asymptote, add the period to it, and you'll get the next one. So you get x is equal to pi over 3 like that. Okay? So that is vertical asymptote number 2. Okay? Is that sensible? Okay, so really the way I look at this now is this, and tell me if this makes sense to you, because you want to make sense of this. What you're doing is cotangent of 3x. So what's 3 times 0? 0. What's the cotangent of 0? Undefined, right? Okay, do this. What is 3 times pi over 3? Pi. Okay. What is the cotangent at pi? Undefined. You see what I mean? Okay, so what you're doing is you're finding the value on the unit circle that when you triple it will give you a place on the unit circle where you're undefined. Does that make any sense? Okay, so that's the methodology you would use. Okay, this one, the period needs to be divided by 4, not 2. That's my fault. So what we want to do is take the period. We're going to do what we call the increment. And let's see, the period, I already forgot. That's pi over 3. When you divide something by 4, you're multiplying by a fourth. So that means the increment, what I mean on that is that's how you make up the x-axis. So your increment is pi over 12. Okay, that's incredibly important when you have a period change. You got to readjust your x-axis. Okay, so what we're going to do is we're going to start with 0, and again, we're only going to graph y equals cotangent of 3x. We're dealing with the period change right now. Then the other two numbers we will deal with in the second step. Okay, so what do? We just start counting by pi over 12. You again don't need to write this out. I like to do this real quick, just to remind you of what in the world I'm doing up here. So I need to just count, and a lot of times I see students do degrees and then change each one to radians. No way, count, get it done fast. Okay, so the first one would be pi over 12. Okay, then 2 pi over 12 reduces to pi over 6. 3 pi over 12 reduces to pi over 4. And let's see, 4 pi over 12 reduces to pi over 3. I'm going to stop there. And I'm going to ask you this. What is so significant about pi over 3? That's the period, right? All right, how many key points do trig functions have? 5. Count them. 1, 2, 3, 4, 5. We made it. Okay, we got a period right there. We fill it out and we're good. Okay, so when you count that increment out 5 times, you should be at the end of the cycle. Okay, now what we're going to do is this. Our asymptotes occurred here and there. So I'm just going to put undefined there, undefined there. Now, all you got to do now is so you don't have to do any arithmetic whatsoever. What happens halfway in the middle? 0. And then the cotangent's backwards. The 1 goes there, and the negative 1 goes there. So if you know that and memorize it, man, you can do this stuff fast. Okay, so this is like 0 there, 1 there, negative 1 there. So if you graphed that, that would be the graph of cotangent of 3x. We just need to finish the whole thing now to put it together. Okay, so what I'm going to do in the next step then is we're going to go ahead and just kind of write out the x values again. So we're kind of keeping track of everything. And what we're doing in this problem is, let's see, y equals 1/2 cotangent of 3x. We got the 3x established. And then we had the, what was that? Is that a minus 2? Is that what that is? Yeah, minus 2. Okay. All right, so let's put it together. Okay, watch very carefully. This is the whole key. So the asymptotes are still asymptotes. They are not affected by those extra 2 numbers. Okay, so now the rest of it is super easy arithmetic. Watch very carefully. You want to make this as easy for you as possible. Okay, that's the y value. So what I'm going to do is I'm going to do 1/2 times that y value right there minus 2. So that's 1/2 minus 2. You can use decimals if you want to. That's 1.5 or 1.5. That's where that went. Okay? All right, go to the next one. The next number is 0. Do the same thing. 1/2 times 0 minus 2. The answer to that is negative 2. Then do it one last time. Do negative 1. So you're going to do 1/2 times negative 1 minus 2. What's that? Negative 2.5, right? Okay, so that's going to give that. Now, there's another thing I want you to notice. I want you to understand this stuff at a very deep level. What's the distance between 1.5 and 2, and negative 2? What's that distance? That's 1/2. And that's the significance of that number. So if you understand stuff like, you will know that your computations are on the right track. Okay, does that make sense? I flattened stuff out, that's why it did that. Okay, so now we're ready to graph. So let me take a real quick screenshot of this thing so I'm kind of refer. You can go ahead and go to the next page and start graphing if you want to. Then we'll wrap it up with what I want to look at here.
It's negative 1.5. Yeah.
What's that? Oh yeah, I didn't do that right. That should be a negative 1.5. I left that off. Okay. All right, so make sure you got the negative 1.5 on there. Okay. All right, now let's go ahead and put this all together. Just graphing through one period. Again, that's negative 1.5. And we'll just go out to pi over 3. Like that. So we'll do pi over 12. Then we'll do pi over 6. Then we'll do pi over 4. And then pi over 3. And we need to go down to at least negative 3. So if you label like that, that should be good enough. Okay, that's just plot points. And let's see what we got. Okay, so we have asymptote at 0, okay, which is just the y-axis. We had an asymptote at pi over 3, like that. And then we had in the middle, pi over 6, we were at negative 2. Pi over 12, let's see, we were at negative 1.5, so just estimate it. Pi over 4, negative 2.5, and then just go through and sketch in the graph right there, and then you got it. Okay, like that. Okay? All right, so that would be kind of the idea of how you do that with just kind of simple arithmetic. If you follow the procedure, you can do tangent and cotangent okay. A lot of times students don't do that well because they deviate from that procedure, but that's the simplest way I've come up with to show people how to do tangents and cotangents. What do you think? Okay, it's all about patterns. Once you see the patterns, you'll have it down pretty easily. Okay, all right, so I just want to finish up with a couple of things. We've already done some of this before. If you're doing these things, these are all in radians. So I just want to do this real quick here and remind you of one real quick thing here. So I'm just going to put in some of these things. You can put this in your calculator if you want to. So if we do tangent of 0.38, I'm just going to round that off to like whatever that is, like 4 decimals. So that's 0.3994, like that. Okay? All right, how do you put a cotangent in your calculator? We've already talked about that. What do you do? Right, you do 1 divided. Now, some of you, if you have that Inspire, I think the Inspire has a cotangent button on it. So you can do that if you want to. That's a high-tech calculator. So I just do it this way, 1 over tangent of 2.01. Make sure that you're in radian mode, and then we'll just do that, and so forth. So that one's a negative because of the quadrant that angle's in. So that's 0.4698, like that. Okay. What quadrant is 3.8 radians in? 1, 2, 3, or 4. You have a 25% chance of getting it right. Where? 3. How do you know it's 3? Because it's a tad bit bigger than 3.14, right? Okay, it's quadrant 3. No stuff like that, okay? So I'm going to get a positive answer because the tangent is positive in quadrant 3. So I have 3.81. It's going to give me a positive answer. If you know stuff like that, you catch mistakes, okay? So I'll round that off. And then the cotangent, we're going to do 1 divided by tangent, 1.88. That's either in quadrant 1 or 2. I think it's in quadrant 2, so it's a negative answer. So that's going to be negative 0.3194, like that. Okay, so just remember how to work out your trig functions of like a cotangent and a cosecant and stuff like that. Okay, I want to finish up with one thing, and then I'll close this off, and we'll lightly start into 7.8 tonight. Okay. Although 7.8 doesn't go to your first test, it goes to the second. I want to kind of go ahead and get that done partially tonight and then partially next week. And then that'll leave us with just reviewing for the test for about 30 minutes or so next Tuesday, if that's okay with you. Okay? All right, no objection. I was going to let you go home, but I guess not.
So wait, you're telling me there's still a chance, right?
What's that?
I thought you were still telling me there's still a chance.
No, there's no chance. Okay, yeah. The what? They were already on Canvas. They're on the, I think in the module for either last week or this week. They're in there. I believe I put them on there. So let's see. I thought I put them either on, maybe I put it in the previous week. I always put them in one of the modules right there. So 7.8, there it is right there. Okay, PDF. Okay. If you didn't print it out, you can just take down what we're going to do. We're just going to do a little bit, and you can transfer it if you want to over the weekend. Okay. Okay, so let me finish up real quick with this thing right here, just doing the period. Okay. So remember the formula is pi over omega when you're doing a period of either a tangent or cotangent. So I just will remind you of that. So if you're doing the period of tangent of 13 pi over 4, that's supposed to have an x on it too, by the way. That's a misprint on my part. So that's 13 pi over 4x. You have to have a variable there. So that's just going to be pi divided by 13 pi over 4. And then we have pi times 4 over 13 pi because I'm dividing by a fraction. And if the pi's cross out, you like it. Students a lot of times freak out when the pi's cross out. That's fine. The period can be anything. It can be just a number that's rational, okay? Then the next one is easy to do in your head. It's what? Pi over 4. Again, that number right there is omega, okay? So you want to be sure that you know how to calculate a period of any of the 6 trig functions. So we've learned them all now.